In this demo, we would like to present several different ways to evaluate the spark of a given matrix based on the theory we have just covered. This program creates a matrix of size 50 rows by 150 columns by drawing randomly the entries of A from an IID Gaussian distribution. As such, this matrix spark is 51, since every subset of 50 columns from it must be linearly independent. We replace the last column in A by the mean of the first 12 columns, and thus the spark drops to become 13, since there is a set of 13 columns that are linearly dependent. Our goal now is to apply computational methods in order to evaluate this spark. How about a direct sweep through all the possibilities of choosing 13 columns out of the 150 in order to verify that indeed the spark is 13? If each such test takes 1 nanosecond, we will need 58 years to complete this computation. So, obviously, this is out of the question. A small note before we begin. Notice that we normalized the columns of A. This has no effect on the spark, of course, but it will ease our treatment later on when we use the coherence. We will discuss 3 methods to evaluate the spark. The first and the simplest of these methods uses the mutual coherence as a proxy to get it. We know that 1 plus 1 over mu is a lower bound on the spark, and computing mu is quite easy. This part of the code performs the evaluation, and we get that the lower bound suggested is 3. The next part of the code uses the bubble function for evaluating the spark. We will not dive into the code, but just say that we have followed the procedure we have described for computing mu1 and then searched for the index that leads to the value bigger than 1. This part of the code performs the evaluation, and we get that the lower bound suggested is 4, which aligns well with the fact that the bubble function is slightly more informative than the mutual coherence. The third approach relies on the upper bound of the spark, which is computed by solving a series of m linear programming tasks. In our case, these are 150 separate problems. Each leads to a different solution, and we seek the sparsest of them. Here as well, we will not dive into every line of the code, and you should invest a little bit of time to understand the steps taken here. This part of the code performs the upper bound evaluation, and we get that the suggested value is 13. This result is superb. It found the actual value of spark in few seconds. We took this code and ran it again, but set the true spark to become 20. While the lower bound remained 3 and 4, the upper bound became 51. In this case, the upper bound is not informative anymore. We could have suggested this upper bound without much effort.